Okay, where are we up to then? What I've done now is abandoned that stupid old piece of strip board that I was trying to use, solderless breadboard that I was trying to use because it was more trouble than it was worth, and I've put these two smaller solderless breadboards together. I've put the chips on top of there and wired them up. What I've done is so far I've wired up just the two counter chips, so that's the low part of the counter and that's the high 4 bits of the counter. They're linked up to these LEDs here, and I've connected up a couple of switches, so I've got 5 volts coming in, and I've connected up a couple of switches. So this is just a bank of 6 micro switches. I've only connected up 2 of them. So this one here is counting up. So what happens is there's 2 lines. There's a count down and a count up line. You keep both of them high, and then you send a pulse, so a low going pulse. These switches are wired up so they're normally high, and then when you press them they go low. So you send a low going pulse on the down line, and we count down by 1. Let's count it down to 0 and back round to 255, and we can count up. So we go up to 255, back to 0, and then we start counting. So by pulsing either the up or the down line, we can count an 8-bit number there, and that's going quite nicely. I mean, I didn't really expect anything other than that. So now what I'm going to do is I'm going to connect up the interesting part of the circuit, which is this latch to latch data in. So I will need to have, what will I need to have? So I will need to have a way of getting data in. So I'm going to be putting data in through my 8-way switch block. That's going to put an 8-bit number in. We're going to be able to clock that number in with a high going clock pulse. So I'll use that switch there probably, or do I need a low going clock pulse? I'll have to think about that. So it's either going to be a high going or a low going clock pulse. I'll clock the data in, it'll go into that latch there. The number will be flowing through the latch when the latch is open. When the latch latches, the number will be latched into these 2 chips here, because I'll also simultaneously pull the parallel load line low or high or whatever it needs to do in order to load data in. I'll store the data in there, and we'll be able to load whatever number I select in binary on these switches. I'll be able to load into the register. Let's see if that works. Okay, well, I'm starting to get a little bit of a mess of wires, but essentially what I've wired up now is the set of switches to feed a value in. So that sort of simulates data coming in on the data bus into the CPU. That goes through the latch, loads into the counter, and then I can count up and down. So we've still got the count up and down working somewhere. Yeah, 1, 2, 3, 2, 1, 0. And we could put a value in, so let's put in 15. So we've got 15 on the switches there, and this is the store button. That stores 15 into the counter. We'll count down, I think, from 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. There we go, we've wrapped around to 255. So if we put in, let's put in 170, so we can store 170. So the binary value that we got there has been stored, and then we could decrease it by 1 and go down. What's an interesting value, I suppose, 254, store that, count up, 255, 0. So that's working really well. So that is clocking in on a low going pulse. Yes, pin 11 of the 74573 is a low to latch. It's the latch pin, and you take it low to do a latch. So when you're high, which is what this switch is normally, data is just flowing through, but you don't get to see the data flowing in because these are not in store mode. When you press this down, I've got the low going latch and the low going parallel load pin of both of the 193s. So both the parallel load of both the 193s is linked together and then is linked to this switch. So when I press this, it latches the latch and does the parallel load, which gets you the data in there, and when you release, the data stays there. So now I just need to wire up 8 data lines from the the value that the counter's storing, which is available here, get it to this chip, and I've realized that it's going to be a lot easier if I do what you should never ever do with chips and put them in upside down. So I'm going to, because all the inputs on this side of the chip, so I'll take 8 wires across to there. That'll be then a high impedance or a tri-state latch, which I can then latch the data in this particular chip. It goes in that side, comes out that side. So this side here will connect back to the data bus, and this register will be complete. That's all the wiring done then. I've got from the number that's coming out of the counter, that is then taken into the tri-state buffer on the output, and this is going in this side of the buffer, it's coming out that side, and then all 8 lines are taken back to here to where the data bus is going to be connected. So that's all I'm going to do for the time being. What I need to do next is get all my registers connected up together and start controlling them and trying to make this thing act like a 6502.